I need to teach you the other things with integration by parts, and it will be fun. The first type is, this isn't the only time that you let your u be the crazy thing. If you also happen to have, like, x to the n inverse tangent of x, or x to the n inverse sine of x, if you have one of those as well, you're going to let the u be the hard thing. Because you certainly don't know what the antiderivative of the inverse tangent of x is. Who would know that, you know? So you're going to let u be the hard thing, just like what you did on the log natural. So let me just show you an example of that. And the classic example is the the integral of the inverse tangent of x dx. Just that alone, you know? And this is what you would do also if, let me just put parenthetically, if someone wanted you to get the antiderivative of the log natural of x, you do the same thing, where I'm telling you, okay, let the hard thing be my u, so I'm going to let u equal the inverse tangent of x, so du ends up equaling 1 over 1 plus x squared dx, okay? And so, oops, yeah. And so let me ask you this, what's my dv gonna have to be?
X, 1.
No? Well, I mean, yeah, but 1 dx. So you get this weird situation where your dv is literally just dx. dv is dx, it's like you said, 1 dx. So my v is equal to x. And that's the sort of thing that would happen here as well, where your log natural would be u, and then your dx would just be dv, okay? And that allows you, that enables you to get the antiderivative. So here, let's go for it, alrighty? So this becomes uv, so I get x times the inverse tangent of x minus the integral of v du. And so I get the integral of x over 1 plus x squared dx. All right? Are you okay that that's my v du? And what do you notice here? What can I do now? Okay. What's that?
Natural law.
Oh, okay, yeah, it ends up being that way, but it's going to end up being a u substitution, and what should I let my u be?
1 plus x.
Yeah, good for you, 1 plus x squared. And now, for this guy, I'm going to have to do u substitution. I'll let u equal 1 plus x squared, and so my du will equal 2x dx. Well, there's my x, there's my dx. I just have to sprout a 2, which means I have to sprout a 1/2. And then I end up with x inverse tangent of x minus 1/2 times the integral of du over u. And that's the only scenario where you are going to get a log natural, as Daniel said. And so I got x inverse tangent of x minus 1/2 log natural of the absolute value of u. And now I can back substitute. What is my u? 1 plus x squared. And by the way, because 1 plus x squared is never negative, you don't need the absolute value symbol. But if you want to put it on, I mean, no one will be mad at you or anything, but I just want to let you know you don't need the absolute value symbol. So anyway, there it is. That's the derivative. I mean, that's the antiderivative of the inverse tangent of x, which I think is a pretty complex thing. I don't know if I want to give you one of these to do on your own. I could ask you to do the inverse sine. Such a hassle. I'm not going to do it. You want to do one?
Forget it.
Forget it? Here. How much more do I have to do? Here, just I'm going to look at my notes. What else am I going to do with you guys? Oh, I got to do that also. Oh my God. Okay, here. Start this one. And can I just get you started? Let your u be the inverse sine of x, so that your du is 1 over the square root of 1 minus x squared dx. Okay, good luck. Can you tell how much I enjoy integration by parts? I mean, it's fun, I guess. I don't know. U substitution is only about 50 times more important. This is example 2. Oh, this is going to be videotaped, right? So I have to pretend that I find this really interesting. Is everyone doing U substitution on this guy that's left over? Hope so. U to the negative a half. Huh. Who'd have thought? Well, anyway, that was fun. You'll notice how I have to be really meticulous in how I deal with my minus signs. I have to write really clearly and non-messy so I don't mess up. Did anyone end up getting this? Did I do it right? You did? Okay, good. Thank you. Then I know we all did it right, or we all did it wrong. So anyway, yes?
Where did the 2 come from?
This 2, I had to take the antiderivative of u to the negative 1/2 du. And to take the antiderivative of u to the negative 1/2, I got to increase the exponent by 1 and then divide by the new exponent. So my new exponent is u to the positive 1/2, and I have to divide by that new exponent, which is the same as multiplying by 2. Yeah. Anything else? This 1/2?
Yeah.
The fact that because I chose my u to be 1 minus x squared, my du is negative 2x, so I had to sprout a negative 2 next to that x to make that whole thing du, which means I had to sprout a negative 1/2 out front. So the negative and the negative canceled to make this a positive 1/2. Anything else? Okay, well now you guys get to do the hardest type of integration by parts. That's choice 3, and that's if you happen to have one that's e to the x sine x or e to the x cosine x. Okay, let's see how that works out for us. I'm sure this will be much fun. Mucho felicidades. Here we go. Example number 3. The integral of e to the 2x sine of x dx. Okay? You guys ready for that? Our first step is to choose u and dv. And remember, you want to choose a u such that the derivative isn't that much more difficult, and you want to choose a d, or you want to choose a u such that, you know, ideally the derivative makes things easier. But certainly you don't want the derivative to make things more difficult, and you want to choose a dv such that when you take the antiderivative, it doesn't make things much more difficult either, you know? So what would you like to be your u, and what would you like to be your dv?
You should be e to the x.
You should be sine x.
How many people say u should be e to the 2x? Well, you guys are correct. But just out of curiosity, how many people said sine x dx? Okay, you guys are correct as well. So it doesn't matter what you choose, right? So me personally, I have this one quirk. I hate fractions. And if I choose my dv, don't write this down, but if I choose my dv to be e to the 2x because I chose my u to be sine x, so my dv is e to the 2x dx, then my v ends up being 1/2 e to the 2x. And I just have a personal, you know, dislike for fractions. Whereas if I choose my u to be e to the 2x, here, if I choose my u to be e to the 2x, now my du is 2e to the 2x, and I don't have any fractions. I actually just sprouted a whole number. So me personally, I'm going to go with u equaling e to the 2x. But if you want to go your u being sine x, that's fine with me. You can do it your way. We'll get the same answer. So anyway, I'm going to choose my u to be e to the 2x, and my du is 2e to the 2x dx. My dv is going to be sine of x dx, and so my v is going to be negative cosine of x. And let's go ahead and plug it in. So now I'm going to have negative e to the 2x cosine of x minus the integral of negative 2e to the 2x cosine x dx. You guys okay with that? Okay. Well, next thing, before I decide what to do, I really do have to simplify those minuses. Okay? I don't want to have a minus. So here, let me get this kind of over here. dv equals sine of x dx. So v equals negative cosine of x. Okay, so this ends up equaling negative e to the 2x cosine of x plus the integral of 2e to the 2x cosine of x dx. Have I made any progress?
No.
Not really. So what do you suppose I should do? Anyone thinking do it again? Because since it totally didn't work doing it once, maybe doing it a second time will work for us? Yeah, let's do that. So let's go ahead and do it again. Okay. What would you like your u to be this time?
Cosine.
Oh, you want to go cosine? Okay. Please do not write any of this down that I'm about to write. Don't write any of this down. But let's say I let my u be cosine of x dx. Oops. I let my u be cosine x, and my du would now be negative sine of x dx. My dv is going to be 2e to the 2x dx, so my v is equal to e to the 2x. You guys okay with that? If I chose wrong and decided to change horses in the middle of the screen, then here's what I get. I get negative e to the 2x cosine of x plus uv which is e to the 2x cosine of x, minus the integral of v du, which is negative e to the 2x sine of x dx. Do you notice what I end up on the right side with?
You do it again.
I end up with my original problem, which is not good, you know? Yeah, these two guys cancel, I'm left with my original problem. So no, you know, just like once you're riding a horse across the stream, you would prefer not to change horses? I mean, I don't know where that saying comes from, but yeah, we're gonna have to actually go with what we started with. So if you're like Fatima, who wanted to do u be sine of x, then you're stuck having to have your u be cosine x. You know, you can't change horses in the middle of the stream. So, and you know, I like to do it like this. I don't like to put the 2 out front and have it distribute. So I'm going to let my u be 2e to the 2x. So my du is 4e to the 2x dx. My dv is going to be cosine x dx. So my v is sine of x. And now I can rewrite this, negative e to the 2x cosine x plus 2e to the 2x sine x. So at least they don't cancel on me, like what happened before. And then minus the integral of v du, minus the integral of 2e to the 2x sine of x dx. Oh wait, v du, that's 4, my bad. V du. So now I've got this thing equaling this thing. What would you have me do next?
Just stop there.
No, we
Why?
can't stop.
Why not? It seems to go on forever.
It seems that way. What is that one? Oh, yeah, I remember a joke like that. Yeah, that went on forever. But I can't say the joke because it's really offensive. But it's one of those jokes that goes on forever. Well, okay. Well, the punchline is, so a man and his servant are driving on a mountain road, and they go around a curve, and they go around another curve, and then the man says, you know, master, when are we going to get there? And the master says, patience, and then fill in the expletive, patience. So, you know, you call whatever you want to call them, like patience, jerk, patience, or patience, something really bad, comma, patience, okay? And so you tell this joke, and you just go on, and then they go around another curve, and then he says, master, when are we going to get there? And he says, patience, bad word, patience. And then finally, after a while, the person you're telling the joke says, when is this stupid joke going to end? And then what do you say? Patience, expletive, patience. Well, that's what this reminds me of. It reminds me of that joke. And so when you ask me, Mr. Shannon, when's it going to end? And my response would be, patience, expletive, patience. Okay, great. All right, great. So here we go. Here's the trick. And I'm going to have to erase this now. Did you guys get all that? Because I gotta erase this. I'm going to rewrite this and see if anyone figures out. The left side is still the integral of e to the 2x sine of x dx, and the right side is negative 2x. Wait, don't give it away. Wait, let me give other people a chance to see it if you found it. And then I'm going to take that 4 out. So what do you suppose I do to both sides of the equation now? What's that, Kylie? No, but good thinking, but you don't do that. Yeah, Carly?
I'm going to add 4 times the integral.
Thank you. We got equaling minus 4 Why not add 4 to both sides of the equation? And that's the trick. That's the big trick. You only have to do this twice. None of that patience, expletive patience stuff. You just add 4 times this integral to both sides of the equation, right? So I'm adding 4 times this integral to both sides of the equation. So now the left side becomes 5 times that integral. And the right side becomes this, negative e to the 2x cosine x plus 2e to the 2x sine of x. Alrighty, and then lastly, I'm going to head and multiply both sides by 1/5. So I end up getting a value for this integral. This integral ends up being negative 1/5 e to the 2x cosine x plus 2/5 e to the 2x sine x, and then plus the constant of integration c. So you guys ready to do one of these on your own?
Yes.
Sure.
That's what I like to hear. Thank you, Angel. And I hope we caught that on camera. Yeah. So the thing is, e to the x, one of these, choose either to be u, but make the same choice twice. Do it twice. So that's it. This isn't like this guy where you have to do it n times. Depending on what the exponent on n is, you've got to do this n times. And it's not like number 2, where you let u be the hard thing, but you only do it once. Here, you're going to have to do it twice, no more, no less. When you see e to the x sine x or e to the x cosine x, do it twice. So here comes another one. Here comes one for you guys. Example number 2. Here, let's do the integral of e to the x cosine x dx. Good luck. Let's see if you guys can do this. Oh, wait, I messed up. It's cosine of 3x. I need to put a number in there just to make it more fun. Cosine of 3x dx. Good luck. Remember to make good choices. And I think this is going to be it. This is all I need to teach you today. Yeah, just do it again. Let's see what people are choosing as their initial U. Oh, so you like fractions, huh, Varsha? More power to you. Good for you. Let's keep going. Now, you know, the antiderivative of cosine 3x is 1/3 sine 3x. And don't forget that 3x. So you chose your e to be cosine 3x. Good for you. Yeah. I hate fractions, that's why I do that. But if you love fractions, if you're in love with fractions, more power to you. It'll work out just fine even with fractions. Yeah, a lot of people love their fractions. I guess I'll do it your way. I'll do it the fraction way this time around. Why not? Because I'm looking at everyone's going with the fractions. Yeah, you're all going with fractions. That's fine. I'm wondering where the 2 is coming from. If that's the 3, like you're kind of copying the previous problem, but you know, you're like literally copying. So remember, it's the sign that has the 3x. Oh, so you want fractions too? Good for you. We love our fractions. Okay, yeah, keep going. I mean, you make good choices, young lady. Yes, it's just the derivative of cosine 3x is negative 3 sine 3x. That's what's meant, you know, but everything else, looks like you're doing it fine. You know, you just have that derivative. Let me see what you chose. Oh, look at you, just propagating fractions. It's working out just fine. Man, look at this. You write so neatly, it's amazing. Okay, cool. Wait, what? Oh, good for you. Okay, yeah, you can do it either way. That's fine. Kind of freaky, but you know. All right. Yeah, you go over the fractions. I gotta show you, the antiderivative of sine 3x is negative 1/3 cosine 3x. Negative 1/3.
Oh.
And you gotta have that 1/3 there. Okay, good. And, so that's correct. Wait, what do you have a cosine? What was I looking at? Wait, your du was sine x? Oh, so that's the second time around. Oh, so the first time around, yeah, this should have been 1/3 sine 3x. Yeah, because you get fractions both times. Yeah, you have to do it again, and you gotta make the same choice. No, it doesn't have to stay with the sign. You just gotta make sure that your u is, or your dv is signed again. But the coefficients don't matter. Yeah, looking good. Wow, yeah, you might actually get a right answer. That's pretty shocking. Shocking.
Yeah.
You guys keep working, but I'm gonna do the version where you get fractions. But you keep working, but I need to put it up on the board or I'm not gonna have time. All right, you guys. Can I just ask, did anyone get this answer? Okay, good for you guys. And let me ask, you guys who got the answer, how many of you chose for your initial u the cosine 3x so that you didn't get fractions? Okay, so all of you except Andrew. So Andrew, you went with the fractions?
Yeah,
And you still got the right answer?
I got the right answer, but I just forgot the sign. I messed up the signs.
Okay, cool. But that still means you didn't get it right. The point I'm making is, in my opinion, avoiding, if you can avoid fractions, that's a good thing. I mean, if you're really meticulous about how you do it, you can still get a right answer. And in fact, all of you guys who went with the fraction strategy, it worked out fine for me, okay? There's a couple things I need you to realize. Number one, after you've done integration by parts twice, this guy should always be a negative. After you've done integration by parts twice, you should always find yourself having to add an integral to both sides of the equation. Like I had to add here, and like I guess I didn't do it in a different color, but do you see how I had to add an integral to both sides of this equation? You will never have a situation where you have to subtract an integral from both sides of an equation. That'll never happen. So if that's not minus, something went horribly wrong. The second thing is, if you have a negative in front of an integral, and now you're going to do integration by parts again, that minus sign is going to have to distribute. So you'll notice I ended up with negative, 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 right? I ended up with 3 negatives here, which which turned that guy negative. You see, the reason this integral ended up being negative is because it was negative, 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 and you've got to distribute that minus sign. So this is very algebraically demanding, this type of problem. Do I have any other questions or issues about this? You're going to get a couple of these problems tonight. Get some practice at it. Yeah, if you can be really careful and write really neatly, I think you can pull it off. But you're going to have to be really careful. All right. Well, any other questions or issues about this? Yes?
Is there any correlation between like the coefficient of like the cosine length x and the denominator at the end?
Yeah, I don't know what it is offhand, but I think it's, I don't know, 1 more than the square of it or something?
Yeah,
Isn't that the way it's working out? If you've only got one of these guys with a number, then it ends up being 1 more than the square. I don't know what I think. Is that what you're seeing here?
I mean, with that one, it's, because the 2x, okay.
Yeah.
Okay.
Yeah, because you end up, every time you have to do integration by parts, you have to multiply, by the 2, where is that? Multiply by that 2 every time, or multiply by the 3 every time. So since you're doing it twice, it'd be squared. And then you end up adding 1 to it, because you got this guy here. I don't know. Any other questions or issues on this? Okay, then the last thing is just, you need to be equipped to just generally recognize, if you've got something that looks like this, that looks like, f of x times g prime of x dx, if you've got something where one of the factors is some function, and the other factor is something where it's obvious to you what the antiderivative of it is, then occasionally you want to just do your integration by parts. Integral of f prime of x g, or I guess I'll just write it like this, g of x f prime of x, where you kind of switch the positions, So, like the problem last night with that secant squared, where it was obvious that your secant squared was going to be your dv because the antiderivative of it is so simple, So that's it. That's your 4th guy. Hey, good luck on tonight's homework.